not a sheet. It's like all like really
All right. Okay, here's the assignment sheet, and notice, look, we have a test next week already. Now, some of you last quarter, you didn't start turning it on to the end. You don't want to do that this quarter because, see, there's two stuffs here. The two things we're going to cover this quarter. That's the easiest thing, and then it's going to get kicked up a notch real fast. So notice that this test is only going to cover two sections, 7.1 and 9.1. So this is where you're going to pad your average right here. Do not wait until later, because believe me, it's going to get tough. Okay, so today's lesson is very short. It's easy. Tonight's homework is very easy. It gets a little tougher tomorrow. It's not that bad. Okay, let me give you a problem. What if you have a circle? Here's the center. We'll call that O for the center of the circle. What do you call this? Here's a radius. Here's another radius, R and R. And let's say you know the measurement of this angle right there. How do you figure out the arc length? Usually in mathematics and physics, we denote the letter S, lowercase letter s to denote arc length. Anybody here taking physics or took it already?
You have to find the total circumference.
Yeah. So anyway, don't you use S to denote we call this the arc length. So what we want to do is we want to develop a formula for the arc length. You don't really need a formula because they ask you questions like this on the SAT all the time. How do you find the entire circumference of a circle? What's the formula for circumference? 2 pi r. And would you agree that this arc length right here is simply some fraction of that circumference?
Yes.
Yeah.
What fraction? Well, for example, like if that angle was 60 degrees, what fraction of the circle is it? 60 over. So normally you will, whatever that angle is, you divide it by 360, right? Because there's 360 degrees in a circle. However, we want to develop a formula where the angle is measured in radians. So instead of dividing by 360, you divide by, how do you convert 360 into radians? 2 pi. There you go. And then look, the 2's cancel out, the pi's cancel out, what's left? R times theta. So the arc length is simply the radius times the angle. That's how you compute arc length. But you have to remember that this angle has to be measured in radians. So if they give it to you in degrees, like they will in tonight's homework, you got to convert it into radians. Now, what about this area right here? How do you find the area of this sector? Same way. What's the area of the entire circle? Pi r squared, right? And would you agree that this sector here is just some fraction of the circle? Yeah, what fraction is that? For example, if that's 60 degrees, you would go 60 over 360, right? So you would go theta over 360. But we want to develop a formula where this is measured in radians. So instead of dividing by 360, we divide by, just like over here, 2 pi, because 360 degrees is 2 pi radians. And then the pi's cancel out. What's left? 1/2 r squared theta. This is a formula that gives you the area of a sector of a circle, and we usually denote that by the Greek letter kappa. Now, a lot of you think that's a K, but it's not. It's the Greek letter kappa. Usually we represent this represents areas in mathematics. Whatever, if you said K, that's fine. Okay? So these are the two formulas that you're going to be using tonight. Okay? This is the formula to find the length, arc length right here. This is the formula to find the area of a sector. Okay, so let me give you two examples. Let's say you have a circle and the radius is, give me a number, 5. No, I don't like 5. 4. And here is the angle, and it has to be measured in radians. So what would be a good radian measurement? How about 1.5 radians? Do you even have any idea what that is? Like 1.5 radians? Okay, let me ask you this. 1 radian. 1 radian is about how many degrees? What would you say? Give me an approximation. What is 1 radian? Okay, anyway, those of you in physics, okay, you guys remember this formula. What did we solve for theta? Theta is equal to S over R. So to find the radian measurement of an angle, what it is, basically, it's the arc length divided by the radius. So whatever arc length of this arc is, if you divide it by the radius, that tells you the radian measurement of an angle. So in order for this angle here to be 1 radian, that means this and this have to be the same length. So can you, it kind of looks like the same length right now, maybe this one has to be a little bit smaller, right? So what would it look like? 1 radian. Okay, you know what? Why don't I just tell you? It's about 57.3 degrees. That's what 1 radian is. It's about that big. That's what 1 radian is. So 1.5 radians would be 1.5 times this would be about what? Okay.
160.
What is half of 57?
75.
What? No, what is half of 57? 28. And then I add 28 to that, you'll get about 85 degrees. So 1.5 radians is about 85 degrees, almost a right angle. Okay, you don't need to know that. Okay? Just compute the arc length right here. How do I compute this arc length right there? Well, you simply use this formula. The arc length is equal to the radius, which is 4, times the measurement of the angle measured in radians, which is 1.5. So your answer is going to be 6. So the arc length here is 6 units, whatever the units are. Okay, now what about the area? How do I compute the area? Well, you simply use this formula. The area of this sector is 1/2 r squared theta. Now we know the radius is 4, so the radius squared times theta. And again, the angle has to be measured in radians, so it's 1.5. There you go, that's your answer. In fact, you write that down on your paper, you're going to get 3 out of 4 points on the quiz. I'm not sure if you even have a quiz, because since this chapter is so short. But on the test, okay, let's say this is worth 5 points, you just got 4 out of 5 points. You want the 5th point, you got to compute that. Well, what is 4 squared? 16 times 1.5, and what is 1/2 of 16? 8. So what is 8 times 1.5? 12. There you go. So the area of this sector is exactly 12 square units. Maybe we should put the units. Units? Square units. So your problems tonight, they're all easy. They're just like this. Okay? But at the end, there's like 4 word problems. I will do one of them for you. And though the word problems are not that difficult either. So the other class wanted me to do number 95, so I'm going to do 95 as well. So does everybody have their books? We're going to try something this quarter. It's called book check. If you have your book, you get -0 off your quarter average. If you don't have your book, -1% off your quarter average. Starting tomorrow. And if you don't have your book, you better have a picture of it, of the assignment. Starting tomorrow. Anyway, so here is the picture in your book that most of you don't have. Okay, it's basically a sector of a circle here. A water sprinkler sprays water over a distance of 30 feet. So the radius of this is 30 feet, radius of the circle. While rotating through an angle of 135 degrees, right there. Okay? What area of lawn receives water? So basically, you want to know, what is the area of this sector? So it's like ridiculous, right? So which formula am I going to use? The arc length one or the area one, since they're asking for area? I think we're going to use this one. So the area of this sector is equal to 1/2 the radius squared, so 30 squared, times the angle measured in radians now. Now, is that angle given in radians?
Yeah.
No, so we've got to convert it to radians. So 135 degrees, hey, that's an angle I know. So from your unit circle, you should already know that angle. Where's 135 degrees? Right there, yeah? What's the radian measurement there? 3 pi over 4. Okay, so hopefully we know 3 pi over 4 now. What if we don't? How do you convert 135 degrees into radians? Okay, some of you remember the conversion. You multiply by pi over 180, but what if you just can't remember anything? Let's do some dimensional analysis then, right? We want to convert degrees to radians. Everybody here to chemistry, you're taking it now, right? So you guys learned dimensional analysis, right? So degrees, we want to get rid of degrees, so we need degrees in the denominator, and we want to convert that to radians, so you put that in the top. See how the degrees cancel out, and then all you're left with is radians? Okay, so what's the conversion? We know that pi radians is equal to 180 degrees, right? And that's how you get multiplying by pi over 180. See, because this is just like multiplying by 1, right? Because pi radians is equal to 180 degrees. So you multiply something by 1, you don't change the value. So, simplify this. 135 pi over 180. What number can go into both 135 and 180? And don't say 5 like the other class. There's something bigger. Okay, let me ask you this. How do I know if 9 can go into both of these? How do I know 9 goes into that? Yeah, you add the digits. 1 plus 3 plus 5 is 9. If 9 can go into that, that means 9 can go into the number. What about this? Can 9 go into that?
Yes.
So if 9 can go into both of these numbers, and 5 can go into both of those numbers, thank you, 45 can go into both. So 45 goes into that.
3.
45 goes into that. 4, and that's how you get 3 pi over 4. But like I said, hopefully that's an angle we're supposed to know, right? From our unit circle. So you write that down on your paper, you get 4 out of 5 points. You want the last point, you gotta compute without a calculator. So how would you do this? 1/2, what is 30 squared? 900 times 3 pi over 4. Can 4 go into 900? The other class, they're trying to think. I don't know. Well, let me ask you this. 9, isn't 900 9 times 100? Can 4 go into 100?
Yes.
Yeah, so 4 can go into 900 then, right? You know what? Why don't we just leave it 9 times 100? Because everybody knows 4 can go into 100 25 times, right?
Yes.
Okay, so that's it. I can't cancel anymore because all I have is a 2 in the bottom and all of these numbers are odd. So that's it. So the denominator is going to have a 2. So basically in the numerator, you got to multiply 9 times 25 times 3 and then you're going to have a pi there. So how do I do that? Well, what is 9 times 25? Now the other class are going, oh gosh, I don't know. Well, let me ask you this. If you had 9 quarters, how much money would you have? Think of it as money. If I had 9 quarters in my pocket, see how come you guys can do that? $2 because it's money. $2.25, right? So what's $2.25 times 3? $6.75. See, you guys can't do it. Just gotta think about it as money. And there you go. So this is your answer. And of course, since they gave the units, it's gonna be square feet. They're asking for the area of that thing, yeah? So I'm sure we'll be seeing these problems on the test, because I don't think we're having a quiz. So the kinds of problems you're going to have tonight, they're so simple. It's like, okay, here, like this picture. This is 4, this is 1.5, find the arc length. Or they're going to say, okay, the arc length is, here, I'll give you some numbers. Arc length is 3, this is 2, what is the angle? They're just going to give you 2 out of the 3 things. How do you do that? Well, use the formula, S equals r theta. I'm trying to find the angle right here, so what is S? What is the arc length? 3. The radius is 2. Can I figure out what theta is? Yeah, just divide both sides by 2. And you get theta is equal to 3 over 2, which is 1.5. So that angle is 1.5 radians. That's all. This is ridiculous. Or they're going to give you this and the angle. Okay, this angle is, how will we just say, 1.25 radians. What is the radius of the circle? Well, again, just use this formula. We know the arc length is 3. We don't know what the radius is, but I do know the angle is 1.25 radians. How do I figure out what r is, the radius? Divide both sides by 1.25. So the radius of the circle is 3 divided by that. Probably the hardest part for you guys is doing that, yeah? How would you do that without a calculator? 3 divided by 1.25. Well, this is what I would do. 3 divided by, change that to a fraction. 1¼ is the same thing as 5/4. And when you divide by a fraction, that's like multiplying by the reciprocal. So the answer would be 12/5. Easy. So this is probably the easiest homework of the entire quarter. Okay, and I'm going to give you the rest of the time to do it. So just like the other class, you got 22 minutes left. You should be able to finish this assignment before you leave this room. Might as well, right? What are you going to do for 20 minutes? Just stare at each other. All right. So I could probably say period 1, everybody finished their homework. What about period 2? That remains to be seen.